Okay, this is the last problem in 2.5. I didn't quite get to this on Thursday. It says construct a polynomial f of x of degree 4 having these zeros. We have x equals -4, x equals 3/5, and x equals 2i. We know some of the characteristics of a polynomial. If it has a degree 4, it's going to have 4 answers. Well, or 4 zeros. We only have 3 of them. Now, something you learned if you look at the very first page of 2.5, something about complex answers, they come in conjugate pairs. Well, that means this is a positive 2i, so the other one is a negative 2i. This is something that you need to be aware of. They come in conjugate pairs, so if I only give you one, you have to know that the other one, like if I gave you the negative, the other conjugate pair would be the positive, or if I gave you the positive, like in this case, its conjugate pair would be a negative. Okay, so now we're going to construct our polynomial. We're going to begin it. Make sure it has integer coefficients. That's important. And when finished, we'll check to see if f of 1 equals 50. Okay, so what we're going to do is we're just going to bring our answers down. Let me move this over just a little bit. X equals -4. We have x equals 3/5. X equals 2i, and x is equal to a -2i. Okay, so when finding zeros, there's some things that you need to be aware of. You need to know where we got x equals a -4. Well, it comes from the factor of x plus 4. Remember, if we had this in factored form, and this was one of our factors, we'd set it equal to 0 and solve, and that's how you get a -4. Now you can do that by going backwards. Let's add 4 to both sides. And we get x plus 4, and that's where that factor came from. Now, we're calling that f of x. This one here, a common mistake is for somebody to just put x minus 3/5, but that would not make this true. We wouldn't have an integer coefficient. You can't have fractions or decimals. So how we got this 3/5, how we got the 5 is we divided by 5. So if we multiplied by 5, we'd get 5x, and then it'd be 5x minus 3. Now again, we can do the same thing that we did over here. I could get rid of my 5 by multiplying by 5, and I get 5x over here equals, these cancel to give us 3. Take the 3 to the other side by subtracting it, and we get 5x minus 3 equals 0. That is how we get 3/5. It comes from this factor right here. Okay, this one's easier. Just take that to the other side, so we're subtracting it. We get x minus 2i. And then this one here, we're just going to add it to the other side, so we get x plus 2i. Okay, so we're going backwards. Okay, now that we have this, we are going to, this is the factored form of this polynomial. Well, we want it to be something x to the 4th plus minus x to the 3rd and so on. Okay, so we want to multiply all this out using FOIL. Okay, we're going to go, now what you're going to do is let's take these two and use FOIL, and let's FOIL those two as well. Okay, the F stands for first, so the first terms, x times 5x gives us 5x squared. The outside, the two outside ones, outside times outside gives us -3x. Inside plus inside, I might as well write that down. Inside times inside, that gives us 20x. And then last times last gives us negative 12. So that simplified gives us 5x squared plus 17x minus 12. Okay. Now we're going to do the same thing. Let me move my paper up. For these two. Okay. Again, first times first gives us x squared. Outside times outside gives us 2x. Let's do 2ix. Doesn't really matter what order you put them in, but that's how I would write it. Then inside times inside, negative 2ix. And then last times last gives us negative 4i squared. Those cancel. Okay. Now, be real careful here. This gives us x squared. This here is going to give us a positive 4. Because we remember, if you remember, x squared is the same thing as a negative 1. So this is saying negative 4 times negative 1, which gives us a positive 4. Okay, now I'm going to, it doesn't matter which way you do it, you're just going to distribute. Okay, I'm going to say 5x squared times x squared gives us 5x to the 4th. 5x squared times 4 gives us 20x squared. Now I'm going to say 17. I'm going to multiply it times everything else. 17x times x squared gives us 17x to the 3rd. 17x times 4, 68x. And now I'm going to multiply this 12. Negative 12 times x squared is negative 12x squared. And then negative 12 times 4 gives us negative 48. Now, that's how I did it this time. Usually I would do the x squared times this, x squared times that, x squared times this, and then distribute the 4. Okay, it will still give you the same thing as what I got. It will just be in a different order. So I'm going to put it in the correct order, and I'm going to combine any like terms that I have. Okay, I got 5x to the 4th. I have a 17x to the 3rd, so that's going to go next. I have a 20x squared and a negative 12x squared, which gives me 8x squared plus 68x minus 48. Okay, so I have a 4th degree polynomial. Okay, and that's what it told me. It says construct polynomial f of x of a degree 4. So far that's right. Okay, now we just need to check it. Okay, I'm going to put a box around it because that is my polynomial. And if it is correct, f of 1 equals 50. Okay, so what we can do is, like always, okay, we can take our 1 and plug it in. Okay, so you can, I don't really know why I'm taking my calculator out, but still, what we're going to do is this here. This is the old way, and I'm going to show you a new way. Which in reality, we're just going to get 5 plus 17 plus 8 plus 68 minus 48. And when you do this, this is going to give us 98 minus 48 will give us 50, and that is what we were checking for. Okay? So just so like what we would usually do is we'd say 1 store x. Got to get it so that my light doesn't have a glare. And then I'm going to type in 5x raised to the fourth plus 17x raised to the third plus 8x squared plus 68x minus 48. And if I hit enter, it should give me 50, and it does. Okay. There is another way. It's called the remainder theorem. Okay. And we're going to throw this in right now because it has to do with synthetic division. It's really cool because when I was just practicing just to make, I did the problem real quick and I didn't do it this way. Okay, I did not check it this way. I did everything up above, I did. But the remainder theorem, what I did was I took all my coefficients and I used synthetic division. I divided everything by 1. So let's do this, the synthetic division. We're going to take 5. Our exponents go down. 4, 3, 2, 1, so that's good. So it's 5, 17, 8, 68, and negative 48. What's really cool is this just happened to be a 1, okay? But if it was a number that was larger than that, and we didn't have a calculator, this is the easier way to do it. Okay, what you're going to find is this remainder will be 50. I don't know why it works, but it does, okay? So watch what happens. I'm going to divide it by 1, okay? So I'm going to bring down the 5. 5 times 1 is 5. Add and get 22. 1 times 22 is 22. Add these two and we get 30. 1 times 30 gives us 30. Add and get 98. 1 times 98 is 98. Add and get 50. That is what the remainder theorem does, and it works for anything, any number, any polynomial, okay? But that tells you that f of 1 equals 50, and that is called the remainder theorem. And that's it.